Okay, hello. So I thought we'd do these handful of slides that I wanted to cover in class. I kind of skipped through them because I was watching the time. Other times when I've done this class, it works, but this week I must have changed my narrative a little. Anyway, we will see these slides again in next class, and we're going to go into more detail about organic chemistry and a bit of the naming. But perhaps it's useful to get to see a little bit of an pre-introduction as such, because even next week will still be an introductory level of it. So what do we have? We have two carbon tetrahedrons, and if you have a single bond, it looks like this. You can have a double bond or a triple bond, and as you can see, as you get more and more bonding, the atoms get closer together and get stronger and stronger bonding. So if you think of it from an electron dot perspective, oh, my pen is already engaged as far as I can tell. I just need to get, where is my mouse engaging? There we go. Okay. Oh yes, it doesn't show up. Okay, so you have an electron here and you have an electron here. So column 4 on the periodic table, 4 dots to represent the 4 electrons, and then you end up with a bond between the carbons. You would need other things fastened on to balance and get all 8 electrons for each carbon. And then over here you would have 2 electrons bonded to 2 electrons. And again, you can have a double bond of oxygen here. You could have single bonds of hydrogens, that sort of thing. So you still have to balance it all off. And then a triple bond. You've got 3 electrons from one carbon bonding to the 3 electrons on the other carbon. It's really hard to draw with a mouse. Okay, now what we have is a carbon ring. And again, you need to balance off. You're going to always have 4 sticks worth coming off of orbitals. So you can have hydrogens or chlorines, oxygen to a hydrogen, different things to balance off. So you'd need 4 different bonds coming off here. And you see that you've got a double bond here and a single bond, and then another double bond. So it's alternating. But what's fun is an electron could go over here, the other electron could go over here. So at any given time, this particular bond might be a single bond or a double bond. And the same with all the other parts. So it can be shifting between which is double and which is single at any point. And what you really end up with, if you were to turn that ring sideways, so you see on a flat plane, you would get a whole ring of like an electron cloud of sharing electrons above all the carbons and below. So often how it's drawn, and you're seeing maybe me in part of this picture, but this carbon ring has, instead of drawing the little some double and some single, you often draw a ring around it instead to indicate that they're sharing the electrons equally. It's 1.5 bonds, which is kind of weird to think about. Okay, so here is some of the naming. This is almost like a small language to learn, to be honest. So there's some little things you can start to learn. Meth here. It is my pen. I don't know why there we go, it's drawing. So that meth stands for 1 carbon. And ene stands for a single bond. So you have a carbon here. And then the little red dots for now, I've just put hydrogens in. You can put other things. So methane is 1 carbon with hydrogens. If you put other things in, you would have to mention like 1 chloromethane if you put a chlorine in. You'd have to name what's different than having hydrogens. And ethane, eth, means 2 carbons. So if you have 2 carbons, that's really hard to draw. And then ene, you still have single bonds. And so anything with anes are all single bonds. If you had propane, you probably have me down at the bottom here, so I'll draw really quickly. Prop means 3 carbons, and then you balance it off with all your hydrogens. And if you have all hydrogens, it would be simply propane. If you put something else in, like a bromine somewhere, you would have to designate where that bromine is, what number carbon-wise, and you would then indicate something like 2-bromopropane can be the type of thing that happens. It just gives you a little sense of this. Okay, so here are alcohols. So our previous slide was fuels, or mainly hydrocarbons, which means it's just carbon and hydrogen. Hydrocarbons, straightforward. This is alcohols, and what that means is you've got an ol part, and the ol stands for you're going to have an OH, oxygen to hydrogen bond somewhere. So meth, 1 carbon, and all single bonds, and then all means there's going to be an OH somewhere. Okay, now if, oh, maybe I'll mention it in the next one, ethanol, eth is 2 carbons, and is a single bond, and all is an OH put on there, oxygen to hydrogen. If you were to put ethanol, okay, so an E instead of an A, that means you have a double bond, and that means you'd have to get rid of a hydrogen to make that work. So you got 1, 2, 3, 4 sticks. That's kind of the way my brain works. If you change that into ethanol, the ine would mean it's a triple bond, and then you would have to get rid of 2 more hydrogens. And then if we look, we got 1, 2, 3, 4 for that carbon. And what do we have for this one? 1, 2, 3, 4 for that carbon. So we're all balanced again. So an or ane is for single, ene is double, and ine is triple. So it's this whole naming that you get to learn about. Okay, so here is a bit about sugars. So sugars are represented by an ose. And what do we have? We have fructose. That is a type of fruit sugar. So sugars can be in a big, long carbon chain. They can be in sort of a carbon ring aspect. And in this particular case, you have an oxygen in the ring as well. And what happens is, to make it easier for printing in books and on the internet, all that sort of thing, all the elbow joints are represented as carbons. So instead of having to draw all the carbons, you put the little elbow joints in. Now, I failed earlier to put that you would have a hydrogen here to balance this all off. And you would also have to look at your, well, your oxygens probably have the balance on them. So you have to make sure that you have 4 sticks coming off your carbons again. And in order to make it easier, you just draw lines for where each bond is. Elbow joints are where carbons are. And then wherever there is a hydrogen, there's the assumption that you can figure out that there's going to be 4 sticks. So wherever we need to balance it off, there'd be hydrogens. Just you get to a point where you get used to, oh, this is balanced off with enough hydrogens to make it work. So like this carbon here, it's just represented by the end of an elbow joint. And we know right away it would have to have hydrogens on the end because it's not showing oxygens, it's not showing bromines or anything else out of the ordinary. So that just gives you a little sampling of what we'll be doing next week. And we'll go into a little bit more detail. We'll take our time and learn a bit more about organic chemistry. So this maybe gives you just a little precursor to next week. So we'll see you soon. Bye.